Welcome, my dear students. We learn detection and measurement of radioactivity. Radioactive radiations can be detected and measured by a number of methods: cloud chamber, ionization chamber, Geiger-Muller counter, scintillation counter, and film badges. Detection and measurement of nuclear radiations by using Geiger-Muller counter and scintillation counter. We study today the Geiger-Muller counter. The Geiger-Muller counter is used for counting the number of particles emitted by radio element. Radiations produce ion pairs when passed through an inert gases or inert gas. The ion pairs migrate towards the electrodes of opposite charge, get discharge and produce a current. Alpha particle produce about 10 raised to 5 ion pairs per centimeter length of their path, while beta particles produce about 10 raised to 2 ion pairs per centimeter path. Means there is a range of alpha as well as the beta particles that can be considered there. The Geiger-Muller counter, this type of a counter was first devised by Rutherford and Geiger in 1908 for counting the number of alpha particles. Later in 1928 it was further developed by Geiger-Muller. It is useful to count alpha as well as the beta particles. Principle of GM counter. It is based on the principle that all type of ionizing radiations possessing different energies produce a current pulses of the same magnitude. When the ionization chamber has a potential between a copper cylinder cathode and tungsten wire anode in the range of 1000 to 1500 volts, the internal amplification is as high as 10 raised to 8. That is, amplification factor is a 10 raised to 8, and the number of ion pairs produced is independent of the primary ionization. The internal amplification is achieved by the application of a carefully adjusted strong electric field between the two electrodes of the chamber. It was it works in the GM counter region. The sample, the construction, then there are two types of GM counter. First, point counter and second, tube or Geiger-Muller counter. They are differentiated mainly by the shape of the electrodes. The outer electrode is a metal tube, is made up from the copper or the nickel, or it is a copper cylinder. Its length 10 centimeter to 50 centimeter and diameter 2 centimeter to 5 centimeter with a thin mica window at one end. The inner electrode is a very fine wire of tungsten about 0.05 mm thick, is suspended at the center of the copper cylinder along its axis. The wire is stretched along the axis of the tube and well insulated from it by means of ebonite plug. The two electrodes, outer and inner, are then placed in a hard glass tube or the glass envelope. The metal tube or the cylinder, that is a cylindrical metal tube, acts as anode, that is the cathode, and it is a negative electrode. The central wire electrode acts as a anode and it is a positive electron. The fine tungsten wire insulated from the a copper cylinder. The cylindrical metal tube is filled with a mixture of 90% argon and 10% ethanol or the bromine vapors or methyl iodide. Argon provides the ion pairs while ethyl alcohol serves as a quenching gas. Ethanol vapors acts as a quenching agent. It prevents the formation of the secondary ion pairs, that is the secondary avalanche, under low pressure 2 to 10 centimeter of mercury. The tube is filled with the argon gas at a reduced pressure, a zero point 0.1 atmosphere. The mica window prevents the escape of gases from the copper cylinder to the atmosphere and allows the ionizing radiations alpha and beta particles to enter the cylinder. The mica window is so thin, the radiations enter in the tube through it, and radiations ionizes the argon atom along its path. Argon get ionized to Ar plus E minus, means electrons released, and positive ions Ar plus for. Lead PB block in which radioactive sample is placed in front of the mica window. The sample of radioactive material is placed in front of a mica window. The positive and negative terminals connected to high voltage source, a potential of 1000 to 2000 volt. The tube is filled with an unionized gas, example argon. The whole assembly is then placed in a lead shield, PB, lead shield. When the ionizing radiations, alpha or beta particles, enter the tube through mica window, they ionize the argon atoms, release electrons. The electrons are accelerated towards the central wire acting as a anode. The electrons produced acquire efficient energy and bring about more and more ionization until an avalanche of electrons and ions, means there is a successive buildup of electron ion pairs called avalanche takes place. The positive ions migrate towards the walls of the tube, that is cathode, and accept negative charge from the walls of the copper cylinder and gets discharged at the walls of the copper cylinder. The secondary electrons cause further ionization under high voltage. Internal amplification is very high, about 10 to 8 times the primary ionization. The multiplication of initial ionization is called as gas amplification. Multiplication of initial ionization is called as gas amplification. The primary ionization produces gas amplification of the order of the 10 to 8. All electrons produced gets discharge at the anode. The pulse of current produced amplified and registered as a count, that is the experimental counts. The counts per minute for a given source of known as experimental counts are recorded with a mechanical register or digital display unit of a GM counter. The current causes a flash of light in a neon tube, and the unit movement of over a mechanical counter, the counts per minute are noted for the given source. Even in the absence of radioactive source, some background counts may be obtained because of cosmic rays or the presence of the minute quantities of radioactive gases like radon or xenon in the atmosphere, that is radioactive impurities, that are recorded with a mechanical register or the digital display unit of a GM counter. Actual counts is equal to experimental counts minus a background counts. From actual counts, the number of particles emitted by radio element can be determined. The heavy or the massive positive ions move towards the cathode at a slow rate that positive ions move slowly and there exists a sheath of positive ions in the vicinity of anode. As a result, the field strength is reduced and the counter becomes ineffective and the second pulse cannot be recorded. The time during which the counter is incapable of responding to a second ionizing event is called as a dead time of the GM counter. After a certain time elapse, the sheet of positive ions moves towards the cathode and the counter is again able to resume counting and record a second pulse. The function of ethyl alcohol or bromine vapor is to prevent a second avalanche which may be generated due to the photoelectrons emitted by the action of photons on the walls of the tube. The photons are emitted when positive ions and electrons combine. The molecules of alcohol or bromine combines with these comparatively low energy electrons and thus prevents the generation of a secondary avalanche. If you plot the counter rate versus applied voltage, the graph will be obtained. That is a curve, that is a threshold voltage, then plateau, and then continuous charge and glow. The GM counter is working at a working voltage at a plateau region. Means there is a longitudinal pulse size, that is a logarithm of pulse size of the counting rate versus the applied voltage. Applied voltage, that is 800 to 1200 voltage, through which there is a GM counter that can operates. In the beginning of voltage of about 100 volts is applied and the number of counts per unit time is noted. The voltage is then increased in stages about 50 volt at a time. The rate of counts goes on increasing when Geiger potential is reached. The number of counts per minute becomes a constant as shown by the horizontal portion in a figure, that is the plateau. The range of potential over which this occurs is known as Geiger plateau. Limitations of Geiger-Muller counter. The GM counter can measure both alpha, beta uh, particles. Voltages used for alpha and beta particles counting as quite different. GM tubes may be used alpha beta counting uh, uh, separately. The efficiency of GM tube is 100% for alpha and nearly 100% for the beta. Means separate GM tubes may be used for alpha and beta counting. It is a limitation. Another limitation, that is the gamma rays cannot be measured or detected effectively because they have very low ionizing power or capacity. The efficiency of GM tube only 1 to 2% for gamma radiation. Certain GM tubes, especially designed to be gamma sensitive, have the bismuth coated cathodes and sometimes steel windows for these tubes. The gamma efficiency may be as high as 8% are found. Since the current pulses are all uniform in size, therefore it gives no information about the energy of ionizing particles. GM counter cannot count particles having a rate greater than a few 10,000, means 10 to 4 per minute. This brings a limit on the use of GM counter when the number of particles emitted per minute by the source is very large. Next, that is a limitation. When the ionization is produced in a cylindrical metal tube, the massive heavy positive ions take more time to reach the electrode cathode surface as they move slowly compared to the electrons. The fast moving electrons reach at electrode anode in a very short time. The electrons being very light are discharged in a 10 to minus 6 second, but the heavy Positive ions require a longer time, about 10 to minus 4 to 10 to minus 3 seconds. Thus, a definite time interval exists between the discharge of the anode, electrons at the anode, and that of the positive ions at the cathode. In this time interval, the counter uh, cannot respond. Hence, this time interval is known as dead time. This is followed by a recovery time, which is varies from 1 into 10 to minus 4 second to 5 into 10 to minus seconds. By 1 to 10 to minus 4 seconds to 5 into 10 to minus 4 seconds. That is the recovery time. If any new particle enters the cylinder during this dead time interval, then GM counter cannot count it. The sum of dead time and the recovery time constitute a resolution time during which events occur. The GM counter, the radiations are not counted. Thank you.